Nestled amidst the picturesque landscapes of the United Kingdom lies a stark reality that's often overlooked: the gradual depletion of its natural resources. While the country's charm may seem unchanging, beneath the surface a quiet crisis unfolds as finite resources such as gas and oil dwindle, challenging the balance between progress and preservation. However, the recent discovery of a mineral nestled deep in the subterranean depths looks set to help the nation cope with this problem and more, potentially injecting up to $130 billion into the country's economy over the course of the next 50 years. This may seem too good to be true, as the mineral in question is a mostly unknown quantity to the general public currently. The mine that extracts it has been designed in such a way to remain indiscernible to the unaware eye, situated 50 meters underground or more and craftily concealed by a sweeping series of farms and fields. So, what is the mineral in question? What makes it so valuable? And what construction techniques were employed to construct what is touted to be Europe's deepest mine? If you enjoy our videos, please like, subscribe and hit the bell. It helps us to keep delivering great content just like this. This mineral is called polyhalite. You'd be forgiven for having never heard of it before, because we hadn't either. Great Britain is currently the only known location to possess such a vast untapped quantity of it, and is the only country currently mining it today. Nestled behind tall, grass-covered berms amid the rolling hills of the UK's North York Moors National Park, the developmental Woodsmith Polyhalite Mine located near Whitby has changed completely from the last time ICIS visited in January 2018, not least thanks to the deeper pockets of global mining major Anglo American. Formerly owned by junior miner Sirius Minerals, Anglo purchased the project outright in a widely publicised £405 million buyout in March 2020, right before COVID brought the world screeching to a stop. So, what is polyhalite? Put simply, this unassuming crystalline substance holds within it the potential to revolutionise agriculture, boost food security, and contribute to sustainable farming practices. It's a complex mineral formed over millions of years, a unique blend of potassium, calcium, magnesium and sulfur. Found in ancient underground deposits, it is often associated with salt beds, and its composition lends itself to a wide array of agricultural applications. One of polyhalite's remarkable attributes is its slow-release nature. When applied as a fertilizer, it releases nutrients gradually, providing crops with sustained nourishment throughout their growth cycle. This not only enhances yield, but also reduces the risk of nutrient runoff, which can harm ecosystems. Furthermore, polyhalite's mineral composition helps improve soil structure. It enhances water retention, reduces soil compaction, and promotes healthier root systems. This can lead to increased plant resilience against drought and other stresses. Anglo American crushes and granulates this mineral to produce their brand name Poly4, which is close to carbon neutral, significantly less harmful to the environment than traditional fertilizers, and costs roughly the same. As previously stated, the mine is planned to be one of the deepest in the world, with its main shafts extending to depths of around 1,600 meters below ground level. The mine will encompass a series of underground tunnels and shafts that will extend several kilometers horizontally to reach the mineral deposits, and covers an area of roughly 62,000 acres. It features an innovative 23-mile underground conveyor system that connects the mine to a materials handling facility in Wilton Teesside, which is a major port area. This conveyor system will transport extracted polyhalite from the mine to the port for processing and distribution. The mine's tunneling is facilitated by a cutting-edge technology known as the Heading Connect shaft boring road header. This technology enables efficient and safe tunnel excavation, reducing the environmental impact compared to traditional methods. The development of the Woodsmith mine has brought significant benefits to the region, including job creation, infrastructure development, and local economic growth, and has placed a strong emphasis on environmental sustainability. The use of underground conveyors minimizes surface disruption, and the project includes plans for a habitat preservation and land restoration after mining operations are completed. In 2027, the mine will begin exporting several millions of tons of polyhalite per year to countries worldwide, and by 2030, this figure is estimated to grow as much as 20 million tons per year. All the while, extensive measures were taken to ensure that there were no eyesores polluting the bucolic landscape. Facilities were hidden within unassuming farm barns surrounded by acres of aesthetically pleasing fields. To the naked eye, this enormous subterranean structure might as well not even exist. Let's now take a closer look at the construction of Woodsmith Mine. The construction of the service shaft was a saga of innovation and resourcefulness, as engineers carved a passage that would give workers access to the pit nearly 1,600 metres below ground. The journey commenced with intensive planning. Enclosed within a barn, engineers meticulously studied the geological composition and structure to determine the optimal path for the 60-metre deep and 30-metre wide service shaft, ensuring its stability and functionality. Innovative technology took centre stage. The previous mentioned Herringcraft shaft boring roadheader method, renowned for its precision and efficiency, was harnessed to bore through the layers of rock and create the vertical pathway. A 45-metre tall tower was also established to lower and lift workers, materials and equipment, but not the polyhalite, which would be raised by a similar adjacent shaft located in an adjacent structure. Construction was not just about excavation, it was about foresight. Engineers incorporated features such as support structures, ventilation systems, and safety mechanisms to facilitate ongoing operations. Walls were lined with either steel or reinforced concrete as the shaft grew deeper, dependent on the formation of the rock in the immediate vicinity. The service shaft is also linked through an underground tunnel situated at a depth of 360 metres to the mineral extraction shaft within the extensive 37-kilometre mineral transport tunnel. This alone is estimated to have cost an eye-watering $3.6 billion. A similar approach was employed for constructing the neighbouring mineral extraction shaft, located in a separate structure. Subsequently, it is transferred onto a conveyor belt that transports it to the extraction shaft, from where it enters the mineral transport system. This system then conveys the material to the Milton Minerals handling facility for further processing. Emerging from the depths, the completed service shaft stood as a monument to human tenacity. Equipped with advanced communication systems and pathways, it would become the vital connection between the surface and the subterranean workings. The service shaft's creation was a collaboration that echoed through time, a fusion of engineering expertise, cutting-edge technology, and an unwavering commitment to safety. Previously, we mentioned the tunnel that carries the polyhalite away to the processing plant in Milton. This incredible feat of engineering could only be carried out by gargantuan machines known as tunnel boring machines, which will be referred to as TBMs from here onwards. These mammoth 2,000-ton machines that stretch the length of a football pitch are purpose-built to navigate through the toughest geological challenges. The terrain beneath Woodsmith Mine was a complex mix of rock, soils and unstable formations. Traditional methods would be slow and unsafe. That's where TBMs come in. 3 were used in total during the construction of the tunnel, and the first was lowered via a special 360-metre deep shaft. The heart of a TBM lies in its massive cutter head. With a diameter as wide as a small car, it's equipped with disc cutters that grind and excavate the rock in its path, at a rate of roughly 20 metres per day. These machines not only excavate, but also create the tunnel walls as they advance. The process is highly efficient, reducing the need for additional support structures. As the TBM advances, a conveyor belt system transports the excavated material away, making space for the installation of precast concrete segments that form the tunnel lining. One of the most impressive features is the pressurized chamber within the TBM, which prevents cave-ins by exerting pressure against the tunnel walls. Inside the control room, operators monitor every aspect of the TBM's progress, and advanced technology allows for real-time adjustments, ensuring precision and safety. The construction of Woodsmith Mine itself is a testament to the commitment to maintaining our planet. The careful restoration of land post-mining ensures that the Earth's beauty is preserved along with its resources. It's not just about extracting a mineral, it's about striking a harmonious chord between progress and looking after the environment. It's a promise that the industries of tomorrow can thrive without compromising the world we inhabit today. As we stand on the cusp of a new era in resource extraction, let's remember that what we uncover extends beyond financial gains. They include a healthier, more sustainable world for generations to come. Thank you for watching. Until next time.